Hello all, welcome to the session. In this video we'll be discussing about hypothesis testing. Before I begin the video, it's my request to please like, share and subscribe to the channel, and please click on the bell icon to receive more notifications on the content related to Python programming or machine learning or data science that would be updated every 2 or 3 days. So let's begin the session. Before I begin the session, I would like to say that if you are uh, studying about this hypothesis testing or learning this topic for the first time, today's video may be a bit vague, right? So what I suggest is you go through this video and go through the next video where I will be doing problems with regard to different types of hypothesis testing methods. And then when you come back to this video will be very clear, and I try to keep it as simple and as meaningful so that you can understand the concept of hypothesis testing very well. So let's begin. So first of all, let's try to understand the overview of hypothesis testing. So when we are talking about, see, hypothesis is not a concept that is just applicable only to machine learning. It applies everywhere. In fact, hypothesis is something that a researcher mainly has to make in order to prove his research or his assumption. But when now we are talking about machine learning, let's connect this hypothesis to the data collection, right? So in machine learning, we know that data collection is one of the very important steps and the first and preliminary steps in machine learning. Now, it's just not enough that when you're doing your work on machine learning, you just collect the data. What is important that you interpret the data, right? So you interpret the data, you give a conclusion to that, and that conclusion can be in a form of a structured outcome, right? So that assumption of structured outcome is called as hypothesis, right? So you have the data, you have to interpret the data, make a conclusion. The conclusion for the data interpretation should come out in a form of a structured outcome, and this assumption of structured outcome is nothing but a hypothesis. So to generically say, hypothesis is a statistical process that will help the researcher determine the reliability of the study. Now there are two types of hypothesis testing. One is, before that, what is hypothesis testing? In a formal definition, it's a statistical procedure that uses the data to validate whether the hypothesis is true or not. Okay, so it's a testing. The testing is done on the hypothesis to check whether the hypothesis made is true or not. So basically you assess the plausibility of the hypothesis by using some sample data. Now there are two types of hypothesis testing: parametric test and non-parametric test. When you are doing parametric test, you do the testing based on parameters like mean, standard deviation, etc. When you are doing non-parametric test, you do the hypothesis testing depending upon characteristics which are independent of the event or the data following a certain distribution. Now, why do we have to do statistical test? Now, statistical test will help us to define the null hypothesis and alternate hypothesis. Now, what is this? We will see this next. It will describe the hypothesis. The statistical test will help us to describe the hypothesis using parameters. We can identify statistical test and statistics. We can describe criteria, which we call it as significance value. The significance value is called as alpha. We will see the meaning of all this in the next slide, and also much more detail in the next few videos with respect to problems. Then we also calculate the probability value. Then we finally take some kind of decision of accepting or rejecting the hypothesis based upon the parameters. So basically the conclusion is what? The researcher will make a hypothesis. Then you do the testing. In the testing, it's nothing but these concepts are involved. These are the statistical hypothesis testing, where you have all these steps that we need to perform. And finally, you have a decision whether the hypothesis will be accepted or rejected. Now coming to, before we go into the steps of hypothesis testing, let's understand two types of errors. No matter how effective your tests are, there can be two types of errors, type 1 and type 2. Now what is this error? This error is with respect to the hypothesis testing. You do a testing, but is your testing correct or not? That also is important, right? The testing is done to check the hypothesis, but how good you are a tester, how good you have done your testing, now that will be measured using type 1 and type 2 errors. So type 1 error is incorrect rejection of a true null hypothesis. Basically, what does it mean? See, I as a researcher, I have done my hypothesis. You are the person who's doing the hypothesis testing, and you made a mistake in your testing where you are saying, where you are rejecting my true hypothesis, true null hypothesis. So as a hypothesis tester, you have rejected my true null hypothesis, that which is incorrect. You have incorrectly rejected the true null hypothesis. This is in other words called as false positive. So such kinds of errors are called as type 1 error. Now type 2 error is incomplete failure of rejecting a false hypothesis, the reverse of type 1. See, I have, as a researcher, suppose I have done my hypothesis, you as a, and in my hypothesis I have actually made a false hypothesis, I have made a false or a wrong hypothesis. You as a tester of hypothesis tester have not identified the false hypothesis. You have not identified the false hypothesis. So that results in a false negative. So that is a type 2 error. Now during the type 1 and type 2 error calculations, it should, very important is, as a hypothesis tester, you should involve the size of the data sample, because now we are talking about machine learning, right? You should keep in track of the size of the data sample which I have used in my hypothesis and which you are using in the testing. So that has to be taken care of. Now there is one word, degree of freedom, which is very commonly used word in hypothesis testing. Basically it indicates the number of independent pieces of information which is used for testing. Okay, so you as a hypothesis tester, how many sample data you're using for testing, so that would be indicated as V, and that's called as a degree of freedom. And basically normally mean or variance is used to indicate this. So when you go to problems, you will come across these concepts and much more clear that would be. Now just let's get into a little bit of math behind the hypothesis testing. So before I get into the math, let's understand that there can be two kinds of important errors. Okay, now this is not with respect to hypothesis testing. This is a different type of error, sample error or actual error, also known as true error. So let's say I have D, which is an unknown distribution. Let's say it's an unknown distribution of data. Let's say x1, x2 up to xn. Now I have a function, right? Target function, we call it as f of x, where I say that the values of this distribution x should have values greater than or equal within this range. It should be within this 0, 1 range. So I have defined my function. Now what is x here? X, I said, is the instance of my data D. H of x is the hypothesis which I have made as a researcher, let's say. And S is a sample set that derives the samples on instances drawn from X. In the sense, I have the data, let's say x1 up to xn. To keep it simple, let's say I have a data of 100 samples. When I'm doing 100 x1, x2 up to x100 I have. When I'm doing the testing, I will take a sample of data. I will not take everything, right? So that sample of data is called as S. Now there are two kinds of errors here. Actual error, also called as true error, where it measures the probability. Remember, it's the probability that hypothesis will misclarify an instance that is drawn at random. Okay, so actual error or true error is misclassifying an instance. So misclassify. Suppose the instance, just to keep it simple, instance, let's say I have an image, right, which is actually having a cancer image, but the hypothesis made is misclassifying it. It is saying that there is no cancer. So that's an actual error. It's a true error. Now, how do you measure it? We measure, see, I am dealing with lakhs of images, right? So how do you measure it? Through probability. What is the probability that how many images are classified wrongly? So that would be actual error or true error. So that's what I'm saying. Since the data set is too large, we cannot really determine the true error for each one. So what we do is we estimate the probability. So with respect to formula, how do you measure the actual error? Error D of H. So H is the hypothesis. What is the error of the hypothesis? PR is the probability where X belongs to D. So X is one of the samples which I am checking, and that belongs to D, which is the total distribution of data, right? And what is the probability that the function or the target function is not equal to the hypothesis function? So what is the probability that the target function is not equal to the hypothesis? So that is the actual error or true error. Now coming to the other error, sample error. Now this is with respect to a sample S. So now this is with respect to a sample S. That's the difference. So it is the probability for instances drawn from X. That is a fraction of S that are misclassified. So here it is the same thing. How many are misclassified only we are going to measure, right? But it is for a fraction of S. So out of a sample which is being measured in the true error, out of that I take a sample, right? So that's why it's called as sample error. So mathematically, how do you say is, here we measure the sample error as a delta value. Delta f of x comma h of x. That's how you measure the sample error. Okay. Now this delta means difference. If this difference is 1, if the function is not equal to hypothesis. Okay, so how do you measure the sample error? You measure it as a delta value, the difference between f of x and h of x. So the delta value will be 1 if the target function is not equal to hypothesis. Otherwise, it will be 0. So I hope this is clear, right? Actual error or true error, both are measuring the misclassifications only, but the difference is in actual error or true error, we are misclassifying an instance which is drawn at random. But in sample error, we are measuring the misclassification of a fraction of S. So here sample error is calculated as a delta value. That's the difference. Now data associated with a sample will have two kinds of errors. Okay, bias and variance. I have spoken about bias and variance before, and as I keep doing algorithms in the next few sessions, I'll be talking about this. So basically, bias and variance is a very common problem. Okay, so when you are doing your work on machine learning, finally all your performance parameters, when they're getting affected, normally it's because of a bias problem or a variance problem. So basically, what is a bias? See, when the data is biased, the error can be estimated. See, when I have done my machine learning algorithm, if there's a lot of bias in my hypothesis, if there's a lot of bias in my data, then it will have more errors. So that error, how do you calculate? Sample error minus this true error. Variance again is the deviation. Basically, it's a deviation. How much is the deviation of the sample error from the true error? So these two quantities are we'll keep seeing in most of the algorithms when we are discussing about it. Now coming to one more very important term when we are talking about the hypothesis testing, p-value is very important. P-value, also called as probability value, it indicates the probability of the hypothesis being true. So finally, when we are doing problems, we might have to calculate p-value. So basically, it is a probability of how much is the hypothesis is true. So basically, this is used to interpret the quantity of the data. So let's say with an example, I have a result, statistical test result. So my statistical testing, I as a researcher, I have done my work. Okay, and I am saying the result has to be 0.05. Okay, so my hypothesis is saying the result has to be 0.05, and you as a hypothesis tester, you have done the statistical test and you are getting a value of 0.03. So you are saying 0.03. So now we are going to compare 0.03 with respect to 0.05. Okay, so this result may be significant. When you are comparing 0.03 with 0.05, it's a very significant value. So there is a difference between the hypothesis 0.05 and the hypothesis testing, that is 0.03. So now here we have some parameters. 0.05 we call it as a significant level. Now this is also a very key value which we will be using when I'm doing the problems. Okay, so 0.05 we call it as a significant level. Okay, it's called as a significant level. In terms of parameter, we represent that by alpha. Okay, remember this when we are doing z testing or chi-square testing, we will be using this. Significant level is alpha. So basically the level I got because of the hypothesis. Now the probability value is going to compare, right, the statistical test with hypothesis testing. Now if the p-value, if it is less than or equal to alpha, then we say hypothesis 1 is rejected. If the p-value is greater than alpha, we say that hypothesis H0 is rejected. Now what is H0? It's the null hypothesis. H1 is the other hypothesis. Okay, which again in detail I will be telling when I'm doing the problems. I will tell the theory and then we'll do the problems. Now coming to one more important term, confidence intervals. Okay, now confidence interval, this also with respect to hypothesis testing. This is done where it basically gives information about acceptance or rejection of hypothesis. So how do you calculate? It is 1 minus significant level. What is significant level? Alpha. Okay, so basically it's a range of value that indicates the location of the true mean. So you have a mean value, so basically it gives a location of the mean value, right? So suppose from the problem you are saying the confidence level is 90%. So if I say confidence level of the hypothesis is 90%, so that means 90% chances are there that the true mean lies in the range. Okay, the 90% chances are there that the true mean, the mean value is lying within the range, and the remaining 10% says that the mean may not be within the range. Okay, so basically confidence intervals, remember, it indicates the location of true mean. And how do you calculate mean and standard deviation? We will see all this in the problems. Now coming to sample error, I've already told you sample error, it is again an unbiased estimate of true error. If no information is provided, then both the errors are same. Now there's also something called as margin of confidence. See, margin of confidence associated with hypothesis is, if I say hypothesis with 95% confidence about the sample error, it means that if I say it means that 1.96 basically indicates 95% of confidence errors. So how do you calculate? Using this formula. Okay, the sample error plus or minus 1.96 to the square root of sample error into 1 minus sample error divided by n. Okay, so it's enough that you just understand that confidence level, it indicates the location of true mean. And if I say confidence level is 90%, 90% chances are that mean is within the range. This is enough now. So when we do the problems, we will give a better understanding of all these terms. Now just to quickly say what is the procedure to estimate the difference between two hypotheses. So this is a procedure. We will do this procedure in the problems. So this is just like a pseudocode or a pseudo algorithm for estimating the difference between two hypotheses. So first step, a parameter d is chosen to estimate the error of two hypotheses. Okay, so let's say I have two hypotheses, h1 and h2. So how do you find the error or the difference between the two hypotheses? Is error d of h1 minus error d of h2. So that gives d. Okay, now the estimated d cap can be estimated as a difference between these two. Okay, so d cap is nothing but the difference between the two hypotheses error. And what is the confidence interval? This is how you calculate the confidence interval, which I showed you in the previous slide. Okay, so confidence interval formula is d cap, which is nothing but the difference between the hypothesis error plus or minus zn. Now this z is nothing but the z value that we will learn in the next z testing. Okay, square root of error from hypothesis 1 minus 1 minus error of hypothesis 1 divided by n1, that is the number of samples which are used in the hypothesis 1, plus error of hypothesis 2 minus 1 minus error of hypothesis 2 divided by n2, that is number of samples used in hypothesis 2. So this is just an algorithm for estimating the difference between h1 and h2. So when we do the problems next, please come back, see this video, it will be more clear. So this is what we are going to learn in the next few sessions. So when we are talking about hypothesis, that these three tests are very important in hypothesis testing. These three tests are very important: t-test, z-test and chi-square test. So basically these tests are statistical tests which is used to compare groups or values. Basically it's used for comparison. So in the next video you can see z-test. So z-test is basically a statistical hypothesis test which is used to determine if there is a significant difference between the sample mean and the population mean. Now what does this mean? We will see the problems. T-test and pair test. Basically this is used to compare the means. This is used to compare the means of two hypotheses. If I say paired t-test, it compares the related groups. We will understand with problems. Third one is chi-square test, where a hypothesis testing is used to compare the categorical variables. So these are the three tests which you will see in next 3 videos in this series. You go do the problems, then you come back to this video. It's much more clear. So I hope the session was useful. So as students, you may get some kind of theory questions here. So please go through the theory, and let's meet in the next session. Thank you so much, and please subscribe to the channel. Thank you.